So I wanted to start off to talk to you guys about your presentations and also your parodies. A couple of people have contacted me regarding this. So I'm going to go over it real quick. So you guys are expected to do a parody. If you guys look at your CHEM group project. So do you guys know what a parody is? First off, okay, so a parody is when you take a piece of music that is like something that's very popular. What is your favorite song right now, Bernice? Or Brittany, either one of you?
Country. It's about the law of the conservation of the mass and energy.
Okay, so like for instance, there's that song, My Best Friend, right? So you take a piece of music like that, and you basically write lyrics to a topic that you're doing or that you're interested in. In this case, you guys were given your topics. Like for instance, some of you guys have energy. So you want to deal with the conservation of energy. And so what you're going to do is write lyrics to a popular song that deals with your particular genre. Each of you guys were assigned a genre. Some of you guys had rap. Some of you guys had rock. Some of you guys had mariachi. Some of you guys, you had various types of music that you were supposed to sit there and pick a song from. And so you pick a song, and usually you want to try to pick something popular that people have heard so that they can recognize the beat, right? And then you write lyrics, let's say again, about the conservation of energy. And I showed you guys at the very beginning an example of that. I'll actually put up another example of some of the parodies that were done in the past. Okay, so then you guys can actually take a look at that, and I'll be posting that up onto the Canvas shell so you guys can take a look at it. So you guys have a clear idea. Now, I've been contacted by a couple of individuals saying, well, you know, we're all in different places. How are you expecting us to sit there and do this? Well, the same way that you guys do everything today, right? Most of you guys communicate by text, by FaceTime, by, you know, basically online. We don't have to be in the same room to sit there and interact and to accomplish a task. And the whole purpose of this is to kind of get you guys used to the habit of working with groups, for one, and then also using the tools that you guys currently know how to use. Most of you guys have cell phones. I would hope that all you guys have cell phones at this point, right? Most of you guys know how to take little videos. You do little Snapchats of yourselves and all of that stuff, right? Some of you guys even do TikTok and those things, right? So what you guys are going to do is you're going to sit there and interact via online as well as using your cell phone to sit there and generate your parody. I had a group of students. I had one student who was actually in Japan. I had a student that was in Nigeria. I had a student that was in Canada, and I had a student that was actually in Mexico. That was actually taking one of my courses, and just so happened they end up all being in the same group together, right? Just so happened. Okay, so and they produced a quality of work that was really good, considering that it was a totally international type of product, right? So if they can accomplish that, I think nobody should have any issues accomplishing it. Okay? So so that's the first thing. So your parody is going to be the first thing. And your parody, again, it needs to be short. It doesn't need to be long. It doesn't need to be the full song. It just needs to be, you know, a couple of the lyrics. At most, you should not exceed no more than 2 minutes for your parody. It needs to be short and brief. And you want to be factual about what you're saying. You don't want to be, I mean, of course, all songs are kind of redundant. They have a hook and everything. But you don't want to sit there and say, energy, 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 and that be your parody. That's not it. You know, you need to sit there and give something that will first capture the audience, something that is factual about the topic that you're talking about to kind of get them interested in it, right? And so the whole point of it is to give them a short, brief intro to what you're going to be talking about, right? Okay, and you want to have fun with it. And so you guys need to sit there and interact and find a way of communicating so that you guys can have a little bit of fun while making it, as well as giving me a pretty decent quality of work, right? Now, I don't expect you guys to be all video editors, but I know that you guys can all use your cell phone and you can all piece things together pretty well because you guys have been doing it since you guys were little. You know, you guys have been introduced to the internet and to your cell phones at quite an early age. So you should be able to accomplish this with no problems at all. The second part of the project is a presentation. You guys have to do a 20-minute presentation. We will have a day for you guys to sit there and sign up. We'll be out the entire day. We'll have a whole day for you guys to come in and give the presentation. And we would like to sit there and have an audience as well. And so I basically, the way I have it set up is that you guys have 20 minutes for a presentation and you have 5 minutes for questions and answers. Okay, so in 20 minutes, I'd like you basically give me a brief lecture on the topic that you guys are given, right? So again, we talked about the conservation of energy, right? So if you have energy or the conservation of energy, then you would give me a brief lecture on the conservation of energy. So each of the members in your group are responsible for contributing to that presentation, right? So that means everybody gets to talk, okay? And so you guys are going to give a PowerPoint presentation on the conservation of energy. Again, it's really brief. It's 20 minutes. It's not a full lecture. So you want to pick and choose what you guys talked about. You don't have to cover every topic, okay? But you want to introduce it and make sure that your students or your audience understand it. So you want to make sure that it's clear and understandable. You don't want to talk over them. And so the last part of it, or not the last, but the next part of it is you have a Canvas page. So each of you have a page that is dedicated to it. You can find that page by groups. You go to groups, you pick your group, it'll take you to your page. There you're going to put the information on the topic that you're given. And so here's an opportunity for you to go in depth and give us more factual information than you had given me before. And I believe I have it set up so that it is a 2,000 word basically essay. So here's 2,000 words that you're sitting there giving to me. Now that's 2,000 words do not include the your bibliography or your references. So you need to make sure that you are citing all the references, all the information that you took it from. Most of you guys weren't born with the knowledge of chemistry. So you have to figure out and find out about it from somewhere. And so most cases, you guys are going to go to Wikipedia, you're going to go to government institution, you're going to go to Khan Academy, you're going to go to all of these different places to try to get that information. You want to sit there and give them credit for the work that they've done. Any images that you've taken from online, you need to give them credit for. Those images should also include the website that you've gotten that image from at the very bottom of the image. And part of your page, you want to also have images. Now, those images and the text that are involved in describing those images, that does not count towards your word count. Your word count is just your word count. So you're going to have a total of, it'll be 2,000 word paper that you guys have to do. And again, this is a group project. So each of you guys are going to be responsible for it. So that also means that you guys need enough time to sit there and go over it so it flows and it makes sense from one individual talking to the next individual talking. You want to make sure that all your formatting is correct, because I will dock you on formatting. And what I mean by formatting is that we're working with chemical formulas in most cases, and you want to make sure that you're including your chemical formulas, right? When you're talking about your chemical formulas, you need to be using the superscripts and subscripts appropriately. You want to be using the coefficients appropriately, right? And then you want to make sure that you're, and you know, when you're spelling out sodium, you have capital N, capital A to represent sodium, right? So you want to make sure that your format is correct. If you do not have correct formatting, you will be docked points for that because you're giving a presentation. You're putting your face on it. You want to make sure that it's very clear. Okay? Do you guys understand that so far? Anybody not understand it? Okay, good. Okay, so again, you only have 2,000 words. 2,000 words is not a lot. Everybody thinks it's so much, but it really isn't a lot. So you want to sit there and pick and choose the topics that you're talking about. You want to go in enough depth that a person can understand what they're doing. You should have examples, you know, and think about it. If you had a little brother or a younger cousin that you're trying to teach chemistry to, how would you sit there and explain it to them? You don't want it to be written in a way that they can't understand it, you know? And then the last thing is that you're going to do what we call peer review. Peer review is basically means that you get to grade your group members, right? Your peers, right? So what you're going to do in that case is that the people that are all in your group, you're going to give them a letter grade from A to an F based upon their contribution to your project, right? Now, this shouldn't be a personal vendetta or anything like that. And, you know, we're all busy, right? We all have things that we have to do, but we all decided that we're going to take this class. So that means that we have to participate in this class. And this is a way of me determining how you guys are participating, and then also your group members to determine how you're participating. If you do not interact in terms of the project, if you do not respond to emails, if you do not do, in that case, you want to definitely give that person an F, right? If they've contributed nothing to the project at all, you want to definitely give them an F, right? Don't be nice. They could be your best buddy. They could be your sister. They could be your brother, right? If they did not contribute, don't give them a grade they don't deserve. And at the same time, there are going to be personal differences, right? You're not going to always agree on things. Part of working in a group is learning group dynamics and how to deal with a group, right? And then how to convey information to a group, right? When we do this, we want to be sure that we are being fair and just. You know, again, you have a schedule that you have to keep. Everybody has a schedule that they have to keep. You know, you want to try to work with everybody's schedule, right? The best you can. And sometimes you're not going to be able to get everybody in a meeting at the same time. So you're going to have to make compromises. You're going to have to be able to communicate by email, by text messages, by voicemail. I mean, you're going to have to use all your tools available to sit there and get this accomplished, right? So you want to take that in consideration. So you don't want to sit there and dock somebody because they couldn't make every meeting that you decided the meeting was going to be at this time, but you were the only person that made the decision, right? So you have to take that in consideration, but you should expect them. They still should contribute, right? We need to find ways of contributing. And we've got to be realistic. The way the world is today, we communicate a lot by Snapchat, by Instagram, by all of these means. And so we need to sit there and take advantage of those tools and use them in our everyday lives. You know, a lot of times I was actually in industry, and sometimes we wouldn't actually travel to different sites. We would actually communicate by telecommunications. We'd actually do a presentation via something similar to Zoom. It wasn't called Zoom at the time. And we would have meetings, you know, in that setting. We'd actually have little mini conferences in that setting. And so we'd have to be able to sit there and communicate effectively in that means. Okay. Do you guys have any questions on that? Yes, no? Okay, good. Okay, so again, we want to sit there. You're going to get basically, it's going to be a paper that you're going to submit. I'm trying to make an improvement to make it so it's not a paper that you have to submit. But if I get that done, then we'll do it that way. But currently there is a rubric how I grade you on all of the different topics. And it's actually, if you click on to the CHEM project moiety under modules, then or assignment under the assignment, then it says CHEM group project, then you'll be able to sit there and do it. And I'll actually show you that here in a second. Okay. Okay, so let me see why it's not showing up on your side. Doesn't look like it is. Project. There we go. Okay, so the CHEM project. Okay, so if you go here, let's see, bottom there should be, I don't have it. Okay, so I'll fix this for you real quick too. So there should be a document that can be downloaded. Should have been up top. Okay, so let me go ahead and leave it. Okay, gotta stop sharing, and then let me put it up. Do you guys have any questions? I know I went through everything pretty fast.
For our project, you gave us a topic, the law of the conservation, but like we don't know like to do law of the conservation of the mass or the energy or we
Yes,
don't know.
I said the law of conservation in general. So in that case, I would like you guys to do a little bit of both because they kind of tie into each other, right? So we'll actually talk about in one of the lectures here soon. We'll actually talk about the law of conservation of energy in addition to the law of conservation of mass. So far, you've done the law of conservation of mass. When we talk about balancing equations, that's just an example of the law of conservation of mass, right? So what you put in, you've got to get out, okay? And I will actually show you another example of that as well. Let's see. Okay, so let me see. And so what you guys want to do, again, this is a very broad topic. You know, the law of conservation in general basically means what you put in is what you must get out. I mean, that's a very generic way of thinking about it, right? It also means that, you know, you can't destroy the stuff that you're putting in. You know, you can't, you know, it just doesn't disintegrate or anything like that. It has to go somewhere, right? And that's what happens in the case of energy, and that's the case of mass. So the concept is still the same. Does that make sense? So
Yes.
what I would recommend is, if it were me, I would say, you know, I would talk about, since I said I gave you guys the law of conservation, right? Law of conservation, it can pertain to matter or it could pertain to energy. And so since I gave you both, I would talk about both, but I would say, but we're going to focus in on matter, right? Because that's the one that you guys are more familiar with because we spent a lot of time on it, right? But you want to talk about energy briefly, right? The fact that you can't, you know, just things don't just disappear. You know, energy is not truly created or destroyed. It's just transferred, right, to different forms. Okay. And so you want to sit there and kind of focus on that part of it. So let me also show you what the rubric looks like, and then I'll upload it. Put it on the screen.
This is due to 13, right?
Yes. So your uploads need to be done by the 13th. And then that week, during finals week, what we'll do is I'll have, because you guys are going to be basically doing your final online. for my class, right? So we're going to have that whole week. We're going to set up some times so that you guys can sign up to do your presentations, right? And they're going to be 20-minute blocks. And again, you guys, and I forgot to mention this earlier, in your presentation, right? Your 20-minute presentation, you're going to have 5 minutes of question and answers, right? I would like you guys to ask questions, right? That means that your peers have to ask questions, right? But if your peers aren't around, then I ask questions. And my questions typically are a lot harder than the questions that your peers will ask you, right? So you want to try to encourage your peers to attend your session of your presentation so that they ask questions, because if you get at least 3 questions from your peers, I won't ask a question. If you get 1 question from your peers, that means I get to ask questions, right? And plus I want you guys to sit there and think about what your peers are producing, what they're presenting, right? And if it makes sense, you know, and use it for clarification, right? So
Are we gonna have like a 4th exam?
you're not going to have a 4th exam. Normally what I do what I call, it's going to be like a take-home exam or a group exam. And so I'll put you guys in a group, and then I'll give you guys a couple of questions, and you guys have as much time. You can use the book and whatever to sit there and do it.
But are we gonna have like a exam for the final or not?
Yeah, you're going to have a final exam. Yes. And that's
Okay.
going to be, and that exam is typically all multiple choice, right? So you notice like all my exams so far, they have short answer questions and they have multiple choice questions, right? So they're a combination of both. The final is all multiple choice.
Okay.
Okay. So let me pull this up. Okay, so this is the rubric. So this is what you're going to be currently graded on, right? So your group is going to be graded on. So for your parody, the creativity of your lyrics, your visual stimulation, basically your images and everything like that. The fun factor, was it fun? Was it, you know, exciting? Or did you guys just get up there? Energy, 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 energy. Was it informative? Was the science that was in it, was it good? Did you have balance equations that you showed up there? Were any of the figures clarified? Was your idea original and not stolen? You know, because there's a lot of parodies that are online and everything like that. And I come across them all the time. And so sometimes students want to try to lift something that somebody else has done. And so I don't want you guys to do that. I want it to be original. I want it to be a good idea. Was it kind of organized, or was it just kind of crazily put together, right? And did it meet the length requirement? Were you also in the correct genre? So your clarity for your presentation has to be clear. And what I mean by clear, I mean, because I know that for some of us, English is not our first language. I mean, when I talk about clarity, I mean the concept of the idea, right? Was the idea presented clearly? Was it, you know, and so if you get up there, and of course, I don't want you to be shy. I want you to give a great presentation, you know, so I want you guys to practice and everything like that, you know, but if your ideas were all over the place, then I'm going to dock you for clarity. Was your presentation, was it organized, right? Did you guys, you know, did somebody just jump in and cut you off every 5 minutes because you said something that was wrong? Or other things. Bernice, we'll talk about the homeworks and everything like that, because the Canvas shell is screwed up because the Canvas shell and the last semester, the Canvas shell and the Chem 101 page were not truly linked. They were just kind of linked. And so I had to do it a different way when I did your grading, but now they're truly linked. And so when things show up on your Canvas page, that's when it's going to be showing, I mean, not on your Canvas page, on your Chem 101, that's when it's due. The Canvas page is kind of whack because I have all of these other assignments because I didn't get a chance to kind of link those together. So they kind of pop up independently of each other. And then when I turned on your other modules, they automatically turned on, even though I had them turned on. And so I need to fix that. And so I'm going to try to go in here in a moment after we get through with lecture and fix those issues. And I need it because I do, what do I say? I'd like to have them there for backup purposes. And so I didn't want to delete them. And I need to figure out a way of turning them off real quickly because this has been a problem. As soon as I turn something off, somehow it pops back up on. And so I need to figure out why it keeps doing it as well. So we'll talk about that here in a moment, but let's first talk about this rubric so that I can get this off and get you guys kind of clear on this. Is that cool? Okay, so, and I have to be honest with you guys, part of the problem that I'm having is that I took on too many responsibilities this semester. I initially wasn't supposed to be teaching at Harnell. They asked me sometime in the summer, it's just like right before classes were getting ready to start, if I'd teach a class. So I was only going to be teaching a lab, and then it was supposed to be one lab. Then it went from one lab to 3 labs, and then it went from 3 labs to the whole class. And so now I'm teaching a whole class, and so I wasn't prepared as much as I should have been for some of the issues that I was having with Canvas. So, I apologize for that. And again, it's a lot more than I was anticipating. So next semester, I will, and I know it doesn't help you guys right now, but I'll have a lot of that cleared up beforehand because I know that I'll be teaching a full class. And again, I apologize. I know that there were things that were happening with other faculty members that had planned to come on board, but with COVID and everything, there's a lot of things that ended up happening last minute. So I apologize for all of the issues with the Canvas page. So again, with your presentations, your visuals, your figures, those are going to be very important. And you also want to make sure that you include that citation. So that those things are going to be incorporated in that grade. If you're lacking a citation, it's going to hurt your grade in that area. And I kind of have it broken down how I'm grading you. And then your page itself, so your page rubric, it basically, you need to include a link to your parody. You also want to upload your presentation. You also want to write the 2,000 words, right? So it's going to be 2,000 words. It's going to has to have organization. It has to be scientifically accurate. Your chemistry, it has to be, your chemical equations have to be balanced. You have to have the correct formatting. The subject matter has to be accurate. And again, you want to make sure you have images and tables to help get your point across. Have you guys ever read it's bad. Have you read a comic book? And have you read a book? Or manga, or have any of you guys read manga or just a book in general? No? I would hope you're reading a book daily because you guys should be taking this class and reading this book, right? So could you imagine having the chem class without images or examples or figures?
Yeah, it will be difficult to understand.
Exactly. It would be horrible to understand. It would be the worst book ever, right? And so that's exactly the same thing for your pages, right? If you guys are just putting, just text up there and everything like that, it's kind of dry. And if I fall asleep on it, that means that I'm probably going to give you a bad grade on everything, right? So you want to make sure that you guys include those images and those figures as well. But also, if you get them from other places, make sure you give credit to where you got them, okay? And so, as I said, the last part of it is your peer grading. And so basically, you're going to give every member in your group, including yourself, an A, a B, a C, a D, or an F, okay? Questions? Okay, good. Okay, so let me attach this to our page. Were you guys, was I sharing my screen? Oh yeah, I did. Okay. Attach this to the page real quick. It should have been there already. It's not. And this is the other thing about having multiple classes. Sometimes
Oh,
I
are
think I
we
did.
having lab this week?
Yes, we're going to have lab this week. On Friday, we will I can't even talk. We'll actually be doing 2 experiments. Well, actually, no, we're going to be doing 1 experiment. It's going to be the balloon experiment. And so what you guys are going to need, you're going to be needing baking soda, and you're going to be needing your vinegar for this. Okay.
What happened if like we tried multiple times to contact like our group members, but only 2 people are responding. Yeah.
Okay, so make one final attempt and say, hey, this is my final attempt. If you do not respond, I'm going to assume that you're not going to be part of the group. And I'm going to, we're just going to continue without you. And so you just start working independent of that. I'll also have to take a look. There's a lot of people who basically have dropped as well. And so I'm going to clean up your groups. I'll try to clean them up later today once I figure out who's inactive and who's active. Yeah. So, is that clear?
Yes.
Okay. Yeah. It looks like every group has at least one person that is currently inactive. And I wish that it would do it automatically, but we have to go in and do it in Canvas. It doesn't do it once they leave. So, any other questions? So you at least had a few people contact you.
Yeah. But
Yeah,
well, we tried to meet like last week, but only one person and me attend. And we during the week we tried to like send them some emails, but they didn't respond. Yeah.
Okay, so I'll send a mass email to everyone. Okay, so let me do that because a lot of them aren't even responding to anything. So I need to send. Okay, so I'll do that right now. And Bernice, not Bernice, Brittany, do you mind sharing your screen with me? Sharing your screen with us so that I can show people about your presentations?
Yeah,
Okay.
but I'm not in a computer right now.
Okay.
That'll be okay?
Yeah, that's fine.
Okay.
That's fine.
So you want to show the Canvas page?
Yes, the Canvas page, yes.
Okay, just give me a sec.
Okay.
Can you hear me?
Yep, I can hear you and I can see your screen. Yes.
Okay.
Perfect. Let's see. I wonder, groups. How can you see your groups, the groups that you're in? Yeah, there we go. If you click to that other page, if you go down to people, please. Okay, so that lets you know all of the people that are in your group. Okay, and so I'm saying this, I know you know the people that are in your group. And so this is how you would sit there and know all the different people that are in your group. The way that you would interact with them is that if you go to the inbox.
Oh, yeah, inbox. Okay.
Okay. Go ahead and hit plus. If you hit subject, it says select subject course. I'm sorry, select a course. Let's see. I think if you hit the chemistry, and then if you hit your plus, if you go down to student groups, okay, at the very top where it says, Why do you have two different groups? Oh, there. I guess it lists all your groups. It shows everybody's group. Okay, so then you can sit there and select all the people that are in your group and then send them an email.
Yeah, I already tried this. Like, I'm sending them emails. Well, Canvas inbox through the app. Yeah, but there's only one person that answers.
Okay. Alyssa, huh? Okay,
Yeah.
so.
Is there anything else that I need to show?
Nope, that's it.
Okay.
Thank you so much.
I'm gonna stop.
Thank you. So
What
how
were
is
you
lecture?
saying?
I said, how is lecture working out for you guys?
Good, but for the Canvas page, it's like a little bit confusing, but it's okay. Yeah.
Yeah, no, it's okay. I mean, I need to work on it. It's obviously I've been teaching chemistry in person majority of the time. We were forced to go online, and I thought these, how I did it would be fine, but there's obviously some issues with it. There's a lot of information and I give a lot of assignments compared to a lot of other instructors, and that makes it complicated. So I need to get better at helping you guys navigate the page, and also getting it so that it actually comes online when it's supposed to come online. And that's
also for the labs, for the page that we should be doing, like the page. Yeah, I'm a little bit behind on like 3 labs.
Okay.
Yeah, I don't know if you can help us, like, it's like a little bit confused, like what should I write and this stuff.
Okay. If you actually, I have my very first lecture, our very first lab, the first one that we actually did, the first physical lab that we actually did, we actually went through how to write a lab report, right? How to actually do it. If you go through that and you follow those guidelines, you'll have it perfectly. And I have a video of it online. And so you should actually have that available to you guys.
Okay.
Okay, no problem. Let's see. So let's get through lecture. Oh, why is it not showing up? Did you guys all eat as much as I did for Thanksgiving?
Yeah. Oh, also for the third exam, what chapters does include this exam, the third one?
The third exam, it should include chapters. It's going to include chapters. It'll be chapters. Chapters 2, 3, 4. 2, 3, 5, 7, 11, 13, 21, 6, and then that group exam, which I'm also going to hand out next week, so you guys can start working on it in a group. That's going to include chapters 7, 8, 9. 7, 8, 9. Oh, wait. I'm sorry. And also in the next exam is going to include chapter 8. So you're going to have also 7, 8, 9, and 15. Okay. And then on your final, that's going to include everything plus chapters 4 and 14. Okay. So we're almost done with it doesn't seem like it, but we are almost done with the lectures. So the next part we're going to be talking about is nomenclature. Or inorganic nomenclature. And we kind of talked about this. I had a video for you guys to sit there and take a look at the at my lecture for inorganic nomenclature for your lab, because that's what you need for naming. And you guys, that last lab that you guys did was a naming lab. And so you actually just named the chemical compounds. Okay, so let's talk about that real quick. Okay, so first off, when we talk about chemical formulas are very, very important for us, right? So we need to make sure that we rewrite it the correct way. We make sure that we get the formatting correct. And if you notice, right, here we have water. Water is H2O. Well, it tells us that we have 2 hydrogens and 1 oxygen, right? And this together is a molecule, right? It's acting together. So they're combined together. So it's not independent, a hydrogen and an oxygen. It's together. They're acting as one unit. Okay, so that's going to be very important for us to understand. And I know that most students do understand that, but they don't think of it. So, but when we talk about an element itself, right, can be diatomic, meaning that it could be made up of 2 atoms of the same thing, right? And so we have diatomic molecules. Let me give you an example of a diatomic molecule. Diatomic molecule is your hydrogen, your nitrogen, your oxygen, your fluorine, your chlorine, your bromine, and your iodine. And I've given you at the very beginning, we talked about this and how they exist and what we need to go through and to understand that. So these guys in nature, they will combine together and they're stable in this way. They're not stable independently. So anytime that we're talking about hydrogen gas, we're talking about H2. Anytime that we're talking about oxygen gas, we're talking about O2, right? So it's important for us to understand that. And when we're given that, and those are things that we should know. And if you guys remember, I think I gave you guys a little an anagram to remember. Have no fear of ice cold beer. You guys remember that?
Yes.
Okay. So here, have meaning for hydrogen, no, nitrogen, fear for fluorine, O for oxygen, C for chlorine, B for bromine, and I for iodide. So those are the 7 diatomic elements. And we also have a diatomic ion. We've already talked about ions. Our diatomic ion is mercury, mercury 1. And so mercury 1 is always written this way. Okay, and I'll have to explain to you what mercury 1 means. We'll talk about that here in a second, but keep that in mind, mercury parentheses 1. Now, the Roman numeral 1 represents the charge on each of the mercuries that are there. So since we have 2 mercuries here, each one has a +1 charge. Together they have a +2 charge, okay? And it's diatomic. Anytime that we talk about mercury 1, it always has to be written as a diatomic, okay? Okay, so let's start off. Let's write the chemical formulas for chlorine, arginine, bromine, and krypton. Okay, so what would be the chemical formula for chlorine? Just talk about it. Okay, so we know that chlorine is a diatomic. Have no fear of ice cold beer. So we know that the chemical formula is going to be written as Cl2. Okay, arginine. If we look, we know that arginine is a noble gas. We look under noble gas. We see arginine on our periodic table. We know that that's Ar. Let me pull up my periodic table. we have bromine. We know that bromine is Br2. And krypton is K. Okay? Come on. Oops, sorry, Kr, my bad. Okay? Okay, so when we talk about organic chemistry is been kind of organized in a very classic way. One of the classic ways, or a traditional way, one of the classic ways of organizing it is binary. Binary basically means two. So that basically means that there are going to be two words. So when we talk about the chemical formula, like we talk about sodium chloride or salt, we have sodium and chloride, okay? So the way that we'd write it, we'd always put the element that goes first is typically if we have an ionic compound, and that's what we're going to kind of start off with, is that our ionic compounds. So if we have an ionic compound, we always put the positively charged cation first, and then we put the negatively charged anion afterwards. So when we talk about ionic compound, we typically have we have metals and non-metal paired, okay? Now, we also have compounds that are all nonmetals. So we'll have two nonmetals together, or we could have multiple nonmetals together, or we could have metalloids or nonmetals that are going to be paired up. So in that case, the way that we typically organize our compounds is we organize it in the sense of when we're talking about those non-metal interacting, non-metal compounds, or as we would say, covalently bonded compounds. So those covalently bonded compounds, the way that we would organize those is pretty simple, right? So if we're talking about let's say CO2. So the way it's typically organized is that the one that is the most electronegative, you guys remember what electronegativity is? It's that desire to actually get that electron towards you more so. And we know that fluorine is the most electronegative. So typically when we write a compound, we write it in a binary form. It would be, in this case, like carbon dioxide. Okay, so that means we have carbon going first because it's less electronegative than the oxygen. Okay, so we have a kind of a way of writing it based upon the electronegativity. So the one at the end is typically the most electronegative. Okay, so when we're writing a compound like CO2, we would write this as, we always put the first element that appears first. We'd write that first, so we'd call this guy carbon. And then this is oxygen, right? So, but there's two of oxygens. And so when we're talking about covalently bonded compounds, we have to tell how many of them that are present, right? It's not based upon charge because they're sharing electrons, right? Nobody's taking or giving. And so you can't just base things on charge. So we have to sit there and give it what we call a prefix to let us know how many we have, okay? So in this case, we have carbon dioxide. Di meaning two, okay? And so the second one, instead of putting out oxygen rather than writing out oxygen, we said oxide. So we drop that ending for oxygen and we put the "ide" in. That lets us know that we're at the end of the molecule, right? So that means that you're telling me that this is the end of the molecule and this is what it is, okay? So we also have cases where we use the common name, like water. We don't call water dihydrogen oxide. We just call it water, right? And so there will be always the case that we will use traditional names. So one of those is for for water. One of them is for ammonia. Okay, so NH3 is always called ammonia. And it's also written as N being first and H being at the end, which is kind of different than what you normally see, because normally you would put the most electronegative at the end. Nitrogen is more electronegative than hydrogen. Okay. So let's talk about those prefixes. So if we have 1, we use mono. If we have 2, we use di. If we have 3, we use tri. If we have 4, we use tetra. If we have 5, we use penta. 6, hexa, hepta. For 7, octa. For 8, nona. For 9, and deca for 10. Just like we did for organic chemistry, right? So when we were trying to tell us how many of things that we had, these are the ones that we use, although we didn't use mono, okay? Is there a question? No question? Good. Okay, so here's another example. If I have CO, right? So we would call this guy carbon monoxide. Okay, we have 1 carbon, so we would just, it's understood that it's 1. So that very first word, if there's only 1 of them, we just use just carbon. The second word, we have to let us know that it is a single. So in this case, we call this carbon monoxide. NO. So this guy is called nitrogen monoxide. But you'll also see it written as nitrogen oxide. Okay. Let's see, is there a question? So when the name has Roman numerals, we use the Roman numerals to let us know the charge on the ion, the positive ion that we're looking at. So like I said, mercury 1, the Roman numeral 1, represents the charge of that Roman numeral. And I'll give you an example of that here in a second, but I want to get over this first. So when we're talking about covalently bonded molecules, we're going to be using the prefixes, right? And so we're not going to be using the Roman numerals. So we want to make sure that we understand when we're talking about covalently bonded molecules. Things that only bond covalently will be your metalloids can bond covalently, and your metals, your metalloids and your non-metals, okay, are going to be able to combine, bond covalently, okay? And occasionally you'll have other ones that are kind of break rules and stuff like that. So for instance, beryllium acts as if it's a non-metal, even though it's a metal, okay? So it'll actually bond covalently rather than bonding ionically, okay? And again, we'll talk more about that in a second. Okay, so for each below, write the formula and name, okay? So it's dinitrogen pentasulfide. So how many nitrogens is that? Di. Bernice? 2. Okay. So we have 2 nitrogens. And then pentasulfide, 5. That's right. So then we'd write S5. It's an S, and here's 5. Although they look almost exactly the same there. There we go. Let me fix my S. Okay, so N2S5. So that's how I would write dinitrogen pentasulfide. Okay, what about dinitrogen pentoxide?
Two nitrogen.
Okay, so N2. And pentoxide. Yep, O5. That's right. Okay, into O5. Now you'll notice that instead of putting penta, we drop the A. And the reason that we drop the A is because oxygen starts with a vowel. And so we don't want to put A, O, right? So we just drop that A. And oxygen, anytime you work with oxygen, it'll actually do that. Okay, now iodine is a little different, right? So if we have iodine, we typically, let's say we had di, we still use diiodide, right? So you use that di, and then you still have the I, which, you know, is kind of weird because you do want the oxygen, but you don't do it for the iodide. So let's try this one. What would this guy be called? So 4, what is the prefix for 4? Okay, so the prefix for 4 is tetra. Tetraiodide. So tetraiodine, since iodine is first, so we write its full name. And then how many oxygens do we have? That's right, we have 9. Here, but Bernice, you got a question? Because in the chat you started something. Okay. So there's 9 oxygens. So then we're going to use that prefix nona. But we wouldn't say nona, we would put known oxide because we dropped the A. Okay. So you'll see the difference between iodide and oxygen. So in the case of iodide, we don't drop the A, we keep it. But oxygen, we drop the A. Okay, and then the last one. Since there's only one, phosphorus, we have 2 ways that we could write this. We could say monophosphorus, but in most cases, since it's the very first one, we would just say phosphorus. And then how many fluorines do we have? We have 5 fluorines, so then we would use what prefix for 5? That's right, we'd use that pent, but it would be penta since it's not oxygen involved, so pentafluoride. And you'll notice, again, for the fluorine, we drop the INE and we replace it with IDE. That lets us know that we're at the end of the compound. It's kind of like, hey, it's like putting a period on it. Okay, this is that compound. That's it. Okay, so this is that case of binary. Now, occasionally you will have cases where you won't have binary compounds. You'll have three things, right? So let's say, for instance, we had okay, let's say we had this compound. Okay, N2SO2. Okay, so N2 would be what is the prefix for the N? So since there's two of them, we'd use what prefix? Di, that's right. So this guy would be dinitrogen. Sulfur. Dioxide. Okay. Questions? Okay. So, and again, this deals with covalent bonds. Okay. Oops. Okay, so we've talked about monoatomic ions, the cation, which is positive, and the anion, which is negative, right? So we know that a positive cation, like let's say we have calcium, right? And if we're putting, let's say, fluorine. So we have calcium and fluorine. If they're going to come together to form a compound, we know that the calcium, which is in group 2, it's a group 2 metal, it wants to get rid of those 2 electrons. Because we remember that from chapters 13 and chapters 12, not chapters 13, chapters 12 and chapters 11, right? So calcium is going to want to become 2+, and fluorine wants to become minus. So it's going to transfer the electrons. So calcium is going to drop its electrons and fluorines are going to pick them up. Okay, so, but we're going to need 2 fluorines to balance out each of the calciums, right? Because this guy is going to be a 2+, and each of our fluorines are going to be a minus. So we're going to need 2 of them to sit there and balance it out. So when we write the chemical compound for calcium fluoride, we'd put Ca F2. So ionic compounds have to be balanced, right? So their charges have to be balanced. So they have to be perfectly neutral, ionic compounds. But if we're talking about just the ion, this guy would just be called the calcium ion. We know that it has a charge of +2 because it wants to get rid of 2 to be like the noble gases. Now, the transitional metals are going to be totally different, right? They're not guaranteed to have a specific charge, right? Some of them will spend, the majority of the time at a certain charge, not always, but the majority of the time, like silver. Silver is always going to, in most cases, will be a +1 charge, okay? So the most of the time that we see silver in a compound, it's going to be +1. But we know group 2 metals are always going to be a +2 charge. Group 1 metals are always going to be a +1 charge, okay? So let me show you that on the periodic table. And if you guys are getting confused in any way, let me know. Okay, so just a reminder, these guys here, these are all group 2 metals. Group 2 metals are always going to have a +2 charge when they form ions. When they form ions, they will have a +2 charge. Okay, so like for instance, calcium, it has a +2 charge when it forms an ion. Now it can exist as a metal by itself. So when we're talking about just calcium, we just write Ca. But if we're talking about the calcium ion, it's always going to have a +2 charge. And when it's in a compound, an ionic compound, it's always going to have a +2 charge. And that charge is going to be understood, but it's going to be balanced out, like in the case of our calcium fluoride. So we don't put the charges up there. Okay. Group 1 metals are always going to be a +1 charge. Now the transitional metals and the post-transitional metals and the lantanoids and the actinoids and even the metalloids in some cases, right? So these guys, they can be different charges, right? And because they can be different charges, we have to use a Roman numeral to tell us the charge, okay? So the transitional metals, we are going to have to use a Roman numeral to let us know the charge that they are, right? The only ones, there are a few of them that we don't do that for, and one of them is silver. Silver is always going to be +1. So whenever you see silver, like silver chloride, you know that it has a +1 charge. It always is going to have a +1 charge, okay? And there are a few of those, and I'll talk about those here in a minute, okay? Are you guys clear so far? Good. Okay, so let's do another example then. Let's say we have rubidium and nitrogen, and they're going to form a compound. So what's going to be the charge? Oops, sorry. Rubidium. My bad. That's a B. Fix this. You can tell it was a really good break because my head is not functioning the way it should. And nitrogen. Okay, so if I have rubidium and nitrogen and they're going to form a compound, then what is going to be the charge on the rubidium ion? Remember, group 1 metals are always going to have the same charge. So Rb is going to have what charge?
Positive.
Yep, it's going to have a positive charge. So it's a +1, so we just put a plus. So we put Rb plus, okay? And this guy would be called, when it's by itself, all alone, it's called a rubidium ion. And nitrogen, when it's all by itself, is called we'd call this the nitride ion. Okay, and it would have a -3 charge because it needs 3 electrons to be like a noble gas. So it's going to gain those 3 electrons. So if we're putting these 2 ions together, how many rubidiums will we need to balance out that -3 charge of nitrogen? You're going to need 2 more. That's right. So we're going to need a total of 3. So okay, so we're going to need a total of 3 to balance out that -3 charge. So we'll put Rb3. So when they come together, it's going to be Rb3n. Okay, and then this guy is going to be called rubidium nitride. Okay, and you notice that we didn't put ion because we know that it's an ionic compound, but they balance each other out. So there's no charges on them because they've been balanced out by each other. Okay, and like this guy was called calcium fluoride. Okay. Okay. Questions? Any questions? Or are you guys good? Okay, so let's go back to the lecture then. Okay, so now when we're naming these compounds, you'll notice that we always put the positive, the cation first, and then we put the anion last. So a lot of times, the way I determine whether somebody has used Google to try to get answers, because Google doesn't always obey the rules of IUPAC, but you guys should, right? And so some people will be putting Google things up there and they'll put fluoride calcium, right? And that's wrong, right? It should be called calcium fluoride. And so that's how I know that a lot of times people will use Google to try to get answers to tests. And so you want to make sure that you understand the rules so you don't get caught doing something dumb. And plus, it makes it easier for everybody else to understand. Okay. Okay, so this basically just tells you everything that we just talked about. So we want to make sure that we give that charge, we represent that charge. And the compound itself has to balance each other out. If we're talking about just the ion, we have to make sure that we're putting the charge up there and we're putting the correct charge for it. Okay. Okay, so here, if we wanted to name this, we know that we would name this guy bromide, right? And then this guy, although it's missing its plus, this guy would be called barium ion. So this guy would be called the bromide ion, and this guy would be called, type it out, and then the Ba would be called the barium ion. Okay, so the formulas for the potassium and the fluoride ions would be K. Let's see, actually, let's go to periodic table so you guys can see where calcium is at. I mean, not calcium, potassium is at. So if we look here, we have potassium right there. So we know that the symbol for potassium is K. And since it's a group 1 metal, it's one away from being a noble gas. So it's going to have a +1 charge. It's going to want to get rid of that 1 electron. So it'll be just like a noble gas. So it'll be it's going to be K plus. Okay. And then for the fluoride ion, fluorine is here. It's one away from being a noble gas. If we gain 1 electron, it's going to be like neon. So then we know that that guy is going to be F minus. Now let's say if we had calcium and fluoride in the solution together, what's going to happen is that they're going to form, because it's a +1 and a -1, they're going to form KF. Okay? They're not going to form FK. Oops. Okay. Okay, we know that that's wrong. okay? Because the cation always comes first, okay? Question? Concerns? Cash? Okay. Okay, let me see over here. Okay. Okay, so we've talked about those transitional metals. So those transitional metals, those lanthanoids, so these guys, they have to be told, okay? So transition basically means change. These metals are going to change their charge. They're not going to obey the rule, the octet rule, right? And so we can't just assume that they're going to be a certain charge associated with it. Like I said, there are going to be only certain ones that we can make that assumption. And like I said, I'll give you the specific one that I know on top of my head is silver. That's what I use. Silver. Okay. Silver is always going to be a +1 when it's written by itself. If it's silver 2, then we know that in that case, it's going to be silver 2. And it can be changed. Okay. Now, we're going to be using those Roman numerals to let us know the charge associated with that ion. So for instance, if we have iron, so the symbol for iron is Fe. Now, that's when it's neutral. That's when it's not charged. Now, if iron loses 2 electrons, it becomes Fe2 plus. And it becomes Fe2 plus. Okay, so the way that we would write that ion, we would write that as iron 2 ion. So we use that Roman numeral 2 to let us know that ion. If iron lost 4 electrons, what would be its charge? That's right, we'd use Roman numeral 4. So we'd write it, the symbol, the chemical symbol for that would be Fe 4 plus. And if we were typing out the name, we would call this the iron Roman numeral 4 ion. Okay, so iron 4 ion. Pretty simple. Okay. Okay, so if it lost 3, we'd call it the iron 3 ion. Okay. So yeah, so if we have F, it'll be Fe3 plus, and we'd represent that as iron 3 ion. Okay, and then I told you guys that mercury 1 is diatomic, and that is our special case, right? That is a special case. So anytime that we're talking about mercury 1, we know that it has to be shown as a diatomic, okay? And so we have to adjust our balancing out based upon that diatomic, okay? We'll get to that here. Okay, so the names of Mn2 plus and Mn3 plus. So chemical symbol Mn is what? Look on our periodic table. Mn, oh, manganese. Okay, so we know that the chemical symbol for manganese is Mn. So then what would we call Mn2 plus. So we would call that manganese. Roman numeral 2 ion. And for the Mn3 plus, we would call that guy manganese 3 ion. Okay, so if we have the nickel 2 ion and the nickel 3 ions, how would we write the chemical formula for that? What would be the symbol for nickel? Okay, that's right. So for nickel 2, it'd be Ni, and we want a superscript 2 plus. And we want to make sure that we pay attention to that formatting. I know it's kind of hard on when we do it on Canvas because it's not intuitive, but there's actually a little button that you can press that allows you to do superscript. And there's also one that allows you to do subscript. Okay, so when you guys are making your pages, you want to make sure that you include that superscript in that subscript. Okay, so that would be nickel 2 plus. And then what about nickel 3 ion? That's right, Ni 3 plus. Yeah, unfortunately on Zoom, we don't have the ability to do superscript, which at least I don't know offhand other than using some other script, which I can't do. So I can't remember how to do it. Okay, questions, concerns, Cash? Okay, so let's move on. Okay, we also have what we call polyatomic ions. Okay, I gave you in that sheet a list of all the polyatomic ions. You guys can use that sheet. I don't push memorization as much as some of the other instructors do. You should know them. And the way that you know them is by using them. The more you use them daily, and I give you guys enough assignments that they should start to stick, that things will start sticking in your head a little bit more. The more you use it, the more you'll remember it, right? That's like if you see somebody every day and you talk to them every day, you're going to remember their name. Where if you see somebody once every 3 years, you're not going to remember their name. So that's the same thing with the polyatomic ions. And so I hand it out to you guys, but you should be using it consistently. Okay. So the way polyatomic ions work are, for instance, the symbol NH4, right? So this guy has a special name. This guy is called ammonium. This is the ammonium ion. And so you want to remember that. That guy's called the ammonium ion. And what it means is that the nitrogen in the ammonium ion is covalently bonded to 4 hydrogens, okay? But it has a +1 charge. So overall, it has a +1. So if you guys remember when we were drawing our structures, our Lewis dot structures, so we'd have a nitrogen. Nitrogen in the center, we'd have a hydrogen here. We'd have a hydrogen here. We'd have a hydrogen here. And we'd have a hydrogen here. Okay, we'd have this guy in brackets to let us know that it has a +1 charge. So we've already really talked about this, right? We've drawn a Lewis dot structure for this, so we kind of understand what it means. So that basically means that it's lost 1 electron, and in most cases it does that so it will obey the octet rule, okay, or make a stable structure. Okay, so that's the same thing with the hydroxide ion. Okay, so in this case of the hydroxide ion, we have hydrogen attached to the oxygen, and it has electrons surrounding it. It has that one additional one to make it balanced, so it obeys that octet rule. Okay, and it has a negative charge associated with it. Okay, so this guy is called the hydroxide ion. So if you look on the list of your polyatomic ion tables, let me see if I can pull that up. Okay. So these are all the common polyatomic ions you guys are going to run across. So we have bicarbonate, we have, which is HCO3 minus. We have, and it's also called hydrogen carbonate as well. So bicarbonate or hydrogen carbonate means exactly the same thing. Bicarbonate is its common name. Hydrogen carbonate is its formal or IUPAC. Okay, we have acetate, we have ammonia, which we just talked about. This is arsenate. This is arsenite. You'll notice that when we have the ATE, the arsenite, AT often means that there's an oxygen present. Sometimes it'll mean that there's a sulfur present. And occasionally you'll get down here where you have, so like for instance, we have SCN. This guy is called thiocyanate, right? So instead of having an oxygen there, they have the sulfur. The sulfur also is signified by the thio, right? So usually if you have thiosulfate, in this case, we have sulfur in addition to having the oxygens, okay? So typically if you have an 8, it has an oxygen associated with it. So ATE, ITE, those guys are going to have oxygens. IDEs, IDE, aren't going to have oxygens associated with it. They're going to no longer have oxygens. Like this guy's called cyanide. That's the combination of carbon and nitrogen, cyanide. Okay. Okay. So you want to be familiar with this, right? And so after you use it a lot, you get used to using it, it'll start sticking in your head. The more you use it, the better it'll stick. Okay. Questions? Concerns? Cash? And you'll notice they all have the charges that are associated with it. This guy, acetate, has a -1 charge, right? So when anytime that you see C2H3O2, you should automatically start thinking, okay, this is probably a polyatomic ion. Now, if it has a metal in front of it, you know that it's a polyatomic ion, okay? Now, but if you see this, C2 H3O 2, we know that this guy isn't because it doesn't have a charge associated with it, right? And so we would name this dicarbon trihydrogen dioxide, okay? Because there's no charge associated with it. But if we see it in the context of a metal, say we have Na, C2, H3O2, then we know that we would call this guy sodium acetate, where this guy would have been called dicarbon trihydrogen dioxide. Okay, so we know that this guy is an ionic compound. This guy is a polyatomic ion in this case because of the metal. You have the metal and the nonmetals. Okay, does that make sense? So when we get to acids, I'm going to throw a curveball to you. Okay. Okay, so let's see what we can do. Okay, we're going to pull up our polyatomic ion table. Let's say we have this compound. Let's say we have iron or cyanide. Okay, so iron 4 cyanide, the way that we'd write that, we know that the iron is going to have a +4 charge. That is a capital F, I know. And then cyanide, it has a -1 charge normally, right? So since cyanide has a -1 charge, so we know that the iron is going to be a +4, and the cyanide is going to be a minus. Okay, so how many cyanides will I need to balance out that +4? That's right, I'm going to need 4. Now, again, these are going to be bonded together by ionic bonds or electrostatic charges, right? So these guys are going to be connected together. So when we write the compound, the chemical formula for the compound, it has to be written as we have to use the parentheses to let us know that we have 4 cyanides. So this lets us know that we have 4 cyanides bonded to that iron. Okay, ionically bonded to that iron. Okay, and we don't put a charge here because it has to be completely charged. It's not an ion anymore. It's neutrally charged. It has a total of a 0 charge associated with it. Okay, questions? Okay, so these are your common polyatomic ions. You guys can use the sheet on the exam, but at some point you're going to have to learn it, right? So you're not required to memorize it, but the more you use it, it's going to start sticky. Okay, and you want to try to use it. Okay, questions, concerns, cash. And you'll notice this is how we use that parentheses, right? So we use it to sit there and balance out those charges. Okay, and when we have a compound together, that's always going to stay together, right? So the cyanide is going to stay together, and then the iron brings it together. Okay, so we have 4 of them. Okay, questions? Okay, good. No questions. Okay. Okay, so when we talk about those ionic compounds, we have what we call that formula unit. And that's what essentially what we're starting. We're getting those formula units established. Okay. So if we're going to write the formula for ammonium bromide and ammonium sulfide, okay, so bromide has a -1 charge. We know that bromide. And then we know ammonium was NH4 plus. So how many of each are we going to need to balance each other out? That's right. We're going to need one of each. Oops. Yeah, it feels like a Monday. Okay, so that would be the chemical formula for ammonium bromide. Now, ammonium sulfide, we know that the ammonium is going to be the NH4 plus, and then the sulfide is going to be S2, right? So because it's 2 away from being a noble gas, it needs to gain those 2 electrons, right? So then we put these guys together. This guy is going to be written as NH4 in parentheses, and we need 2 of them to balance out the sulfide, because this has a -2 charge, this has a +1 charge, so we're going to need 2 ammoniums to balance it out. Okay, so then we write this as parentheses NH4 parentheses 2S. That will be the chemical formula. Questions, concerns, Cash? Okay, we'll keep moving forward then. Okay, so let's write the chemical formulas for aluminum. Now, aluminum is a post-transitional metal. Aluminum has a very defined charge. It's always going to be a +3 charge. Okay, we know that aluminum has a Al 3 plus, and oxygen is O2 minus. So we need to find what I call the common denominator. The easiest way of doing this is kind of like by cross multiplying. So you're going to use that color. So a quick way of doing it is if they're not multiples of each other, since 3 is not a multiple of 2, then we can cross multiply, or we can use this 3 as our subscript. So in this case of our chemical formula, we need 2 aluminums to balance out 3 oxygens. Okay, so now if it's a multiple of each other, let's say we have iron 4, the iron 4 ion, and we had sulfur, the sulfide ion, right? So in this case, we don't have to sit there and cross multiply. We just, since this guy's a multiple of this, we know that we're going to need 2 of these, right? So we need to find a common denominator, or a common integer that they have, right? So this guy, they both could have 4 if we multiply this guy by 2. So in this case, we'd have Fe so we'd need 2 of the sulfurs to balance out the +4 of the iron. Okay, do you guys see that? Okay, so if we were doing the barium nitride, we know that the barium ion has a 2 plus, and the nitrogen ion or the nitride ion has an N3 minus. So again, we could just do that cross multiply. Okay, so we'd end up with barium 3 nitride 2. Okay, questions, concerns, cash, Kool-Aid? Okay, so let's do one more. Let's say we had say we had chromium 5 phosphate. Okay, so we know phosphate, and because it has an ATE, we know that it is a polyatomic ion. So if we go to our polyatomic ion table, okay, we go to our polyatomic ion table, and we look up phosphate. Okay, so let's see. Oh, there it is. Phosphate right there. Oh, phosphate has a -3 charge. So let's go ahead and write that down. You know, I'm getting old and I can't remember things the way I used to. So it's PO4, 3 minus. Okay, and we know that chromium, let's see. I believe that is CR. Let's see, chromium. Oh, yeah, CR. There we go, chromium. And it has a Roman numeral 5. So that means that I know that that's going to be CR5. So let's see. So it's going to be CR5 plus. Okay, so now I know the charges on both of these ions. So when they come together and they have to balance each other out completely so that they have a 0 charge, oh man, you know what? I know that 3 can't go into 5, so I'm going to use that cross multiply method. Okay, let's see. Cross multiply. Oops. 3. Let's go over here. Okay, so CR3 has PO4 in parentheses, and I need 5 of them. Okay, and then that would give me chromium 5 phosphate. Okay, questions? Okay, good. No questions. That means that you guys got it. Don't worry about anything, right? Good. Okay, so let's move forward. I'm going to clear this. Ouch. Okay, so we've talked about how we combined it and how it has to have a total of a neutral charge. We've talked about how to incorporate the Roman numerals. The key is that we never want to use prefixes when we're using ionic compounds. Anytime that you use a prefix, the prefix only pertains to covalently bonded compounds, okay? Okay, so if we go ahead and write the names for this guy would be called, we have the lithium ion and the bromide ion. So this guy would be called lithium bromide. This guy is magnesium, and you want to be careful not to mistake manganese for magnesium. It's really easy to do. So it's magnesium, and we know that magnesium is a group 2 metal, so it doesn't need a Roman numeral. Group 1 metals and group 2 metals never need a Roman numeral, so they're always going to have their normal name. Okay, so that's good. Okay, so we know that this guy is magnesium, and then it's an I. I is iodide, so we use the iodide ion. So an ion because it's an ionic compound. Okay, and then this guy, it's Ag3. We know that the charge on nitrogen is 3. So this guy means that this has to be silver 1. So, but I also told you that silver is almost always a +1 charge. So I can get away with calling this guy either just silver nitride, because I know that silver is almost always a +1 charge. So I can just use silver, or I can call it silver 1 nitride. Okay, so the correct answer would be silver nitride, though. Okay, the most correct, I should say. This guy, manganese. Well, manganese can have multiple charges, so we're gonna have to put the Roman numeral on that one. Manganese, and here there's 2 chlorines. So I know that chlorine is 1 away from being a noble gas. So each chlorine has a -1 charge associated with it. So since I know that Cl, it'll be Cl minus. So I'm going to need 2 of those. That's how I get that. So that's how I get those 2. So that means that the charge on this guy has to be a +2, right? So if it's a +2, I need to use the Roman numeral 2 for that. So then I would call this guy manganese 2 chloride. Now you'll notice that the nonmetal, right? We never have to sit there and put a Roman numeral around it or put a prefix on it, because we know that it's always going to be a certain charge. We know that the charges on those nonmetals are, right? Based upon where they're located on the periodic table and how close they are to being noble gases. Okay? Let's move on. Okay. Come on. Okay, now when we talk about acids. Now, acids, okay, so let's start with hydrogen, where hydrogen is located on the periodic table. If we take a look at hydrogen, hydrogen is also located, even though it's a non-metal, it's actually located right above the group 1 metals. Now, one of the reasons it does that is because it has this really weird characteristics. What it'll do, it'll form what we call the hydrogen ion. So in a water solution, hydrogen can form an ion. And we call this guy would be called the hydrogen ion. Now, since it's in a water solution, it will actually physically bind to water, forming a covalent bond and making what we call the hydronium ion, which is H3O+. So this H+, right, it actually will bind and like grab water and like, oh yeah, I love you, I love you, I love you, right? Forming a covalent bond with water and making this guy. Now this guy is what causes acids to be acids, right? That hydronium ion. So, oops, fix this. Oops. Okay. So it'll actually form what we call, like I said, the hydronium ion. And this happens in an aqueous solution, meaning it's in water. Okay. Now, AQ means aqueous, water solution. We talked about that in the past. So you should be very familiar with it at this point. Okay. Now, when we talk about acids, what happens is that certain chemicals or certain acids, they will actually be what we call strong acids or weak acids. Now, strong acid basically dissociates its ion in solution. And so, let's see, go back to lecture. So, for instance, we have HCl. So when HCl is in water, what happens is it'll actually dissociate that hydrogen, it'll kick it off, and that hydrogen will go to the water, and it will form the hydronium ion, okay? And this is considered to be a strong acid. It happens very fast and get dissociation. Now, this is when we bubble hydrogen chloride gas into water. We form hydrochloric acid, okay? Now, the way that we would signify hydrochloric acid is HCl, and we often will put AQ, okay, to let us know that it's in water. Now, if we had HClG, this guy is called hydrogen chloride. Where this guy is called hydrochloric acid. Just by it being in water causes it to behave differently. It forms that ionic compound. It separates, okay? Okay, oops. Spell that. Hydrochloric, not hydrochloride acid. Again, feels like a Monday. Oops. Ah, crap. Okay. Okay, so this guy would be called hydrochloric acid. Okay, so the way I look at it is when an acid separates, it separates into what we call, this guy is called the hydronium ion and the chloride ion. Now, again, strong acids are going to completely separate. Weak acids are going to only partially separate. Okay, and I'll show you an example of weak acids here in a second. Okay, so it separates into the two ionic forms. Okay, so we can kind of use this, the fact that we know that there's a Cl, if we have AQ and the Cl, and there's only hydrogen there, we call this guy hydrochloric acid to let us know that there's only hydrogen there. There's no oxygen present. We'll be talking about what we call Oxyant Acids here in a second, and I'll give you an example of that. Okay, so naming these guys, naming acids, there's a little anagram that I want you guys to remember. My ride has, and I know this is a misspell, hydraulics. Okay, so my ride has hydraulics. And it's also, if you take a look, I think I have that on the side of your polyatomic ion table, or I should say, one of my TAs put it on the side of your polyatomic ion table. Get there. Let's see. There. There we go. Okay, my ride has hydraulics. Okay, so if we take a look at this, IDE, so if our compound breaks up into the chloride ion, we just put ic and then we put hydro in front. So we drop the ide and we replace it with ic, IC, and then we put hydro in front, hydrochloric acid. So if I have H2SAQ, this guy would be called hydrosulfuric acid. Hydrosulfuric acid. If I have H3PAQ, this guy would be called hydrophosphoric acid. Okay, questions? Concerns? Kool-Aid? Okay, good. Okay. Okay, so these are some of the common acid and common acid names. So this guy is called carbonic acid, right? And again, we want to put an AQ there because if we don't have an AQ there, we assume that it's going to be a gas, or so that lets us know that it's an acid. It helps confirm that it's an acid. We have nitric acid. We have phosphoric acid. We have sulfuric acid. We have chloric acid. Now, these guys are called, these are relatively strong acids except for the carbonic acid. Carbonic acid is a weak acid. Okay, so if it has IC on it and it's not and doesn't have a carbon in it, it's going to be usually a strong acid. Okay. There are exceptions with everything. Okay, so we also have what we call Oxyant acids, or I'm sorry, oxy acids. All of these guys have oxygen in it. These guys are called oxy acids because they have the oxygen present. So we use that chloric part of it, right? So if we take a look at the chemical formula for chloric, we take a look at the root here, not the H part of it. We know that the H is going to represent a plus, right? And then this guy is going to be the chlorate ion. Okay, so essentially we're getting the H plus being broken down. I'm going to put this AQ plus the chlorate ion being broken down. And when we put it in water, it's going to dissociate. It's going to separate, kind of like salt does. Okay, now and I like writing it this way rather than using the hydronium ion, even though we know that H plus in water forms that hydronium ion. It's a lot easier to see and balance it out this way. And so this is a more generic way of writing it. Okay. Now, here we know this guy here, if we look at our polyatomic ion table, this guy's called chlorate. Chlorate, ATE. Okay, so since it has an ATE being coming from it, or its root is an ATE, so anytime that you see ATE or a unit that has that ATE ending, we're going to replace that ATE with IC, okay? And put acid at the end. Ic acid, okay? So 8 replaced with, okay? So the way that I remember this is I ate organic apples despite them being poisons. Okay. Now, if we look at our polyatomic ion table, we have let's see, where is it? Let's do right here. So we have sulfate, sulfite, okay? Anytime that we have the acid breaking down to a sulfate ion, let's say we have H2SO4, well, we see that SO4, we know that it's going to break down to 2H plus AQ plus SO4 minus. I'm sorry, SO4 2 minus. Okay, so okay, so we know that here we would call this guy, this acid would be called sulfuric acid. Okay, so we're putting the IC at the end of it because we know that this guy is called sulfate. So sulfuric acid. Okay, so we're basically replacing the ATE with the IC, and we're putting acid at the end. Okay, if we have one less oxygen, and we have not one less, one less oxygen, and we have H2SO3, AQ. Well, we know that that is going to break down into the hydrogen ion and sulfite, ITE. So instead of when it's ITE, we're going to replace it with OUS acid. Okay, and that's how we get poisonous, right? So ITE, poisonous. Okay, so in that case, this guy would be called, so if we have the ion SO3 2 minus, this ion is called sulfite. So then in this case, we would call this acid sulfurous. Sulfurous acid. Okay, so we put the OUS and then we put acid at the end. Okay, now the thing about oxy, these guys are called Oxyant Ions. These particular ions are called Oxy Anions, meaning negatively charged, and they have oxygen in them, right? These guys, there's a little rule. So the starting off point is going to be the 8. So the normal starting off point, we put 8. If it drops down 1 oxygen, it's ITE. If it drops down 1 more oxygen, and we have SO2 2 minus, this guy would be called hypo. Not hypo. Yeah. Hypo sulfite. So hypo meaning under, and then so this guy would be under the ite. So that means it has 1 less oxygen than the sulfite does. Now, if something is more, we typically use hyper. But in chemistry, we didn't want to get you guys confused, or whoever decided didn't want to get you guys too confused. And so instead of using hyper, they said they're just going to use per. So if we have 1 more oxygen than the ATE, right, we would call this guy, so for SO5, 2 minus, SO5, 2 minus, this guy is called per sulfate. Okay, so we're adding one additional oxygen, so that gives us per, like hyper sulfate. Okay, so per sulfate. Okay, so if we're talking about the acid that would form in this case, so H2SO5 AQ. This guy would be called per sulfuric acid. And then this guy would be called, if we had the H2SO2 AQ. This guy would be called Hypo Sulfurous acid. Okay. Questions? Okay, so let's see if we can get this tested out. Okay, so we have our polyatomic ion table out, right? Everybody should have their polyatomic ion table out. And then we're going to actually go through it real quick. And let me see if I can get this little whiteboard here. Okay, there we go. Okay. Okay, so I'm going to clear this out so you guys can. Slide this over. Minimize it a little bit. Okay. Okay, so let's see. Okay, so if I have H2 C2O4 AQ. Okay, so then I know as soon as I see that AQ and I have that those hydrogen in front, the first thing that should pop in my mind is that this is an acid. Okay, so this is an acid. So I need to go to my polyatomic ion table. I need to try to find the root for C2O4. So I want to go to my polyatomic ion table. Oh, C2O4 minus 2. Oh, there's 2 hydrogens. I know that each one is +1, so that would balance it out. So I know for a fact that I have oxalate as my root there. So it ends with ATE. If I remember, it ends with ATE. I changed the ATE to an IC. an IC. So then I would call this acid oxalic acid. And that would be the name of the acid. Okay. Let's do another one. Okay, let's say we had H2Cr2O7AQ. Okay, again, as soon as I see that AQ and those hydrogens in front, I know, man, that's an acid. Okay, so it's an acid. So I go to my polyatomic ion table. I find the one that is for that root CR2O7. CR2O7. CR2. Oh, right here. Oh my gosh, dichromic. Oh, dichromate. Dichromate. So I know that I dropped that ATE, and then I'm going to put an ic at the end. So then I'm going to say dichromic acid. Okay. So let's say say we end up with these acids here. H2 Cr2 O7. I mean O6 AQ. Okay, so again, as soon as I see an AQ, I see the hydrogen, I know this is probably going to be an acid. Okay, so I'm thinking to myself, this guy's an acid. Let me go to my table. I don't see anything that says Cr2O6. But I do have chromate, dichromate here. And I know that if I write this out, let's see, Cr2O7, 2 minus, I know that that guy is called dichromate. So then I know that Cr2O6 would be called minus would be called dichromite. Because I know that when I lose one, it becomes from an 8, it becomes an ite. Just like phosphate and phosphite. And then I know that if I lose another oxygen, this guy would be called hypochromite. dichromite. Okay, so I went from chromate, hypodichromate, dichromate, dichromite, hypodichromite. Okay, so then I know that this guy is going to be called, since it's an ITE, I remember that whole thing about I ate organic apples despite them being poisonous, despite ITE, OUS. So I know that this guy has to be called dichromious acid. Okay. Questions? Good. So let's move on. Okay, so then we're familiar with the acid names. This basically tells us, so we have to pay attention to the number of oxygens that are available. We know what happens in water and how many hydrogens are available. So all of these guys, in terms of naming, if they're in the same group, they're going to behave very similarly. Okay, so this guy, HClO3AQ, that would be called chloric acid. So then HBrO3, that's going to be called bromic acid. And then if I had HFO3 AQ, that's going to be fluoric acid. Okay. And that's the same thing that happens with other chemical families too. So in the case of sulfur, that's a typo, sorry. Sulfur, selenium, and tellurium, those guys are going to behave very similar too. So if I have H2TeO4, I know that that guy is going to be called telluric acid. Okay. Okay, and then that's the same thing with like phosphorus and arsenic. Now nitrogen's a little bit different. Nitrogen behaves a little bit differently. Nitrogen, it doesn't have the same charge as the phosphorus or the arsenic would have because they're lower down the scale. Nitrogen only has its acid is only going to have one hydrogen attached to it. Okay, so it's going to be HNO3, and we call this guy nitric acid. Okay, then HNO2 is called nitrous acid. HNO, that would be called hyponitrous acid. Okay. Okay, let's move forward. So, given the name HSO4 is sulfurous acid, what is the name of H2TeO3? Sorry, given the name that H2SO3 is sulfurous acid, what is the name of H2TeO3? So we know that they're going to behave very similarly. So this guy would be called tellurious acid. Given the formula of perchloric acid, HClO4. What is the formula for perbromic acid? Per meaning an extra. So we know that this guy was going to be HBrO4. Thank you. Okay. Okay, so we had just talked about it. So if we added one more, so our starting point, right? So this guy, we know this guy has an 8, so it'll be an IC, and then acid at the end. If we add one more oxygen, that becomes perchloric acid. So per meaning more, okay? If it's one less than our starting point, then that's OUS. So that's ClO2. And if it's two less, right, it's hypo OUS, okay? And if there's no oxygen at all, we call that hydrochloric acid, okay? So what is the name of H2SO3? And they need to put an AQ there so that we know that we're not talking about dihydrogen sulfur oxide, trioxide. So, but we're talking about an acid in this case. So we know that this guy is called sulfurous acid. And so tellurious acid, which we just named earlier, is H2 TeO3. AQ. Okay. Okay. So, oops, we've talked about the Oxyani Ions, and so you guys should be familiar with how we break those down. I kind of showed you that, and then how you can kind of use that in terms of combination with the acids. Okay, and this is just basically summarizing everything that we just talked about. So we know that this guy is one less than NO3 minus, which is nitrate ATE. So then this guy has to be one less, so that means this guy's called nitrite ion. Hypo Iodide. Okay, so we know that iodate is IO3 minus. Okay, and we know that from a polyatomic ion table. Then we know that this guy is iodite. So then hypo iodite should look like this.
And then I know that per iodide is going to look like this, or per iodate is going to look like this chemical formula. Okay. Questions? Okay. Okay, so this just basically gives us how everything is derived from, kind of like what I was showing you earlier. It kind of helps us understand it. It makes it a little bit clearer. This is just showing you exactly the same table. Okay, so if we wanted to name this compound, we now know that this guy, since we know that this guy would be per bromate, because it's one extra than bromate, we would call this guy magnesium per bromate. So if we wanted to write the chemical formula for potassium, selenite. Okay, so let's selenite. Oh my gosh, I can't remember where selenite is. Okay, let's pull up our periodic table, maybe. If I can find my way to my periodic table. Okay, periodic table. Oh, there we go. Selenite. Oh, it's just like sulfur. Huh. Let me see. Let me see. Sulfur. So it was. Selenite. So that means that. So sulfur was SO3 2 minus. So that would be sulfite. So selenite must be Se O3 2 minus. Okay, and so in this potassium is always going to be a plus charge because it's a group 1 metal. So then I know that my chemical formula must be K2 because I'll need 2 potassiums to balance it out. SeO3. Okay, so I know that would be the answer right there. Yeah. Okay. Okay, so because acids lose hydrogens, they lose them one at a time. They don't lose them all at once, unless it's a really strong acid. And it also just depends on the solution that we're in. Okay, so phosphoric acid is going to lose its first hydrogen. So then we're going to form the dihydrogen phosphate ion. Okay, then if it loses its second hydrogen, then it's going to form hydrogen phosphate ion. And then if it loses its third and its final hydrogen, it's just the phosphate ion. Okay, now this happens with other acids as well. So like in the case of carbonate. So if we have the carbonic acid, it then breaks down to the hydrogen carbonate, which is also called the bicarbonate. Okay. Hydrogen sulfide, hydrosulfuric acid breaks down to the hydrogen sulfide ion. The sulfuric acid breaks down to hydrogen sulfate. The sulfurous acid breaks down to the hydrogen sulfite ion. The phosphoric acid breaks down to dihydrogen phosphate ion, and then the dihydrogen phosphate breaks down to the hydrogen phosphate ion. So the way we would name this guy, well, we know that the hydrogen carbonate ion has a -1 charge. It's always going to have a -1 charge, and there's 3 of them. So that means that this iron has to be a +3 charge. So then we would name this guy iron 3 hydrogen carbonate. Okay. Okay, so questions, concerns, cash? Okay. We have 4 slides left. I'm going to try to finish these 4, and then I'll let you guys go. Okay. So the formula for ammonium hydrogen phosphate. Well, we know the ammonium ion is NH4 plus, and we know hydrogen phosphate is going to be HPO4 2 minus. Sorry, HPO4 minus. No, that's right, 2 minus. 2 minus, that's right. So it's HPO4 2 minus. Okay, so then in this case, we'd have to balance it out. So then we know we're going to need 2 of these guys to balance out that minus charge. So we end up with okay. Questions, concerns, cash? Okay. Okay, so the last thing that we want to talk about, or one of the last things that we want to talk about, are hydrates. So hydrates is just the concept of having water added to the structure. So water is actually kind of bonded to the structure. It's often used to sit there and allow solutions to go into solution better. Like, so for instance, this guy here would be called, we know that this is copper 2, so this would be called copper 2 sulfate penta, and so we would just use the Greek prefixes for the waters. So there's 5 of them, so this would be pentahydrate. Okay, so we just name this guy copper 2 sulfate pentahydrate. Okay, now, because often in chemistry, we'll have to do this, and if we remove water from a substance, let's say we removed it in lab, we want to let everybody know that we removed that water, that it's no longer there, it's no longer hydrated. Okay, so then this copper would then be called copper 2 sulfate anhydrous. So that lets us know that we removed the water from it, okay? And so that we boil the water off. Okay, so the first part, if we wanted to name this compound, this guy would be called sodium carbonate decahydrate. So if we wanted to write the chemical formula for nickel 2 chloride, hexa meaning 6, hydrate, so then we'd write Ni, Cl2, that big old dot, hexa being 6, 6, H2O. And you notice we put the coefficient in front instead of putting it as a subscript. That means that these waters are acting independently to that compound, okay? They're not all tied together, if that makes sense. Okay? Okay, and this is just a summary of all the nomenclature that we just talked about. Hopefully it was clear enough. That's it. I guess I'll see you guys on lab on Friday. You guys have a good day.
Excuse me?
Yep.
Yes. I just arrived.
Okay.
So, I wanna take this time to ask a few questions, if that's okay with you.
Yeah, that's fine.
Regarding the class, I noticed like there's a bunch of people asking about the chemistry 101 homeworks.
Yes.
So just to be sure, they're not there, right?
They're not there yet. There will be some that'll be popping up this week, okay, on the Chem 101. The 14, the 15, the 16, those guys aren't going to be popping up, okay?
All right. And also I wanted to ask if I could do the what's the name? The exam correction for exam number 2, but I see that you haven't graded it.
Yes.
So is it okay if I just?
Yeah, you can go ahead and get started on it. And then the short answer, because really the short answer are the only parts that I haven't, that aren't graded automatically. So if you know that you didn't answer, a lot of times what happens is a lot of students don't answer the short answer questions. They'll answer all the multiple choice questions and they won't give me any answers. If you didn't answer any of the short answer questions, then answer the short answer questions, you know.
All right.
Okay.
Yeah, also for the chemistry project, I have been in contact with my group, but out of the 6, there is only me and 2 other people that are actually talking.
Yes. And that's typical, unfortunately. So what you guys are going to do, you guys are going to work with the 3 people that you have. So you're not going to be graded on whether or not they show. They will be graded on whether or not you'll be graded on whether or not you show and participate in it. And at the end of the semester, you guys get to grade your colleagues. And so if they didn't do anything for the project, then you give them what they deserve. And that's taken into consideration. Okay. Does that make sense?
Right, yes. Yes, okay. Thank you.
Okay.
Yes. Thank you for
Okay.
answering.
You're welcome.
Have a nice day.
You too.
Oh, excuse me. So next week is gonna be the last class that we have like together.
The last lecture.
right?
Yeah. The last
Okay.
official lecture. Yeah. We have a lot to go over too. Yes.
Okay, thank you.
Yeah. But there will be other lectures that you guys are going to quote be responsible for to kind of look over. Okay. So just be prepared.
There's no final, right? Or is it?
Yes, there is a final.
Oh, is it published on
It
Canvas?
is not published yet. It will be published because I have to adjust it based upon, I try to be fair to you guys. I try to base it upon what I've gone over in class. And this class has been kind of a weird class in the sense that it did not work out the way that it should have. So I try to make sure that it's stuff that I've covered to make it fair to you. Do you understand? So,
Yeah.
so I have to
Also,
adjust it. Yeah.
Are we having like a lab for the next week or not? We are just
There will
doing
be
the class.
there will be one final lab for next week. Yeah. So we have the lab this week and we'll have one lab next week as well. Okay.
Oh, and the final is gonna be published like the next week or the last week?
It'll be published after I finish the lecture.
Today?
No, not today's lecture. Next lecture.
Or
Yeah,
okay.
because it just depends on. It really depends on what I get a chance to go over, and we're going to go over a lot next week because there are things that I definitely have to go over. So. Okay.
All right. Yes.
Okay.
Okay, thanks.
Also, there's an extra credit assignment in Canvas, but it's blocked until December.
The do's and don'ts.
The 17th.
Yeah, and usually that's blocked until the end of the semester because you don't know the do's and don'ts until you finish the semester, right?
I guess I don't know. There's no description of the assignment, so.
Okay, yeah, because I usually give it at the end.
Okay, so that. Okay. Thank you.
Okay, no problem.